Hello, today we will discuss force and acceleration due to gravity. This is important because we will later use it to derive the equation of motion for a spacecraft. The equation we derive will essentially be the one derived by Sir Isaac Newton several hundred years ago. It is the only equation required to simulate orbits and is the heart of our 3D orbit simulator. We all know about gravity. It is the force that keeps pulling us toward Earth and prevents us from flying off into space. Newton's law of universal gravitation states that the magnitude of this external force pulling you toward the center of Earth is given by this simple equation that I now show on my right. In this equation, r is your distance from the center of Earth. It is the radius of Earth plus the altitude where you're standing. Uppercase M is Earth's mass, lowercase m is your body mass, and g is the universal gravitation constant. The product gm is equal to 3.986 times 10 to the power of 14 and is a very large number. The force due to gravity on your body can also be defined as your mass times the acceleration due to gravity using the character g. I now show this on the left side of your screen. From these two equations, we see that g is equal to gm divided by r squared. Also note that the acceleration due to gravity is not a function of mass, and it does not suddenly go away at some altitude above Earth. It just gets weaker as you get further away from the center of Earth. If you stood motionless at an altitude of 330 kilometers, about the altitude of the International Space Station, you probably wouldn't notice any change in gravity compared to that at Earth's surface. In the next image, I show a plot of g versus r. According to this plot, at sea level, on the left side of the horizontal axis, the acceleration due to gravity is about 9.82 meters per square second. And at the space station, where is about 6,700 kilometers, it is about 8.87 meters per square second. Therefore, the force due to gravity at the space station is only slightly less than that at sea level. We hope you found this video useful. If so, please give it a like and consider subscribing to the channel. If you want to be notified when new content is added, click on the notification bell. We plan to produce more videos in the future. We also need your feedback, so please leave comments. If you want to suggest subjects for future videos, we want to hear those too. Goodbye.